Now let's talk a little bit more about SQL. SQL is the language you use to write queries in a database, meaning that while it is used in ArcGIS, it isn't exclusive to ArcGIS. You find it in other database software or web apps. SQL is a pretty simple language, especially with how you will use it for GIS. The primary syntax starts with select, from, where, followed by a clause. The query tools in ArcGIS and most other GISs only concern themselves with the where clause part of the SQL query. The select from dataset part is conveniently taken care of for you. Here, I have a screenshot of the older version of ArcGIS, which shows you the start of that syntax. Here, I'm selecting from the layer called NE_10M_ places simple, where the field scale rank is equal to 1 or has a value of 1. There are all sorts of different operators you can use in your SQL query. The simplest is equal. Here, though, you have to make sure that spellings are absolutely correct. If you say misspelled Alcott with only one T in this example here, you wouldn't find the author of Little Women. The regular not equals to sign that we see in math classes isn't on the keyboard, so instead we use this sign for not equals. This operator finds all of the attributes where the department isn't sales. Greater than and less than are probably fairly obvious, but remember that these have to be numerical data to use this. Between is a really useful operator because it allows you to write and find a range of values. Here, we're looking for the field cost, where we have a value between 100 and 500. We use like a lot less in GIS, but in this example, you would find all of the names that have the letters W-I-L-L at the beginning. So things like William, Will, and Willamette would all show up in this query. In also allows you to just list a set of values instead of writing individual queries for each value. Finally, we might have null values in our data set. Don't get too hung up on these. They're just places in the data set where we don't have any data. Say we haven't gotten to it yet, or maybe that place just doesn't collect that types of data for that variable. This is the last row. This last row in this table allows you to find or avoid the null values in your data set. Again, don't get caught up too much with this. So far, we have seen simple queries like state name equals Delaware. But what if we want to find where there are counties that have more than 100,000 people, which also contain a capital of that state in that county? In that case, we use something called relational algebra. These are queries using logical operators. In GIS, these are the words and or. Relational algebra is the basic underpinning of how query languages work. This defines how relations, aka tables, can be manipulated and queried. For instance, an AND clause would select the things that A and B have in common. Let's think about Venn diagrams here, right? This is the area that those places have in common. Let's go through some examples. In this query, we're selecting from our ownership plots shapefile where the area field is greater than 20. Here we've selected plot 1 or 2, 4, 5, and 6 because those have values that are greater than 20. In this query, we're doing an AND query where we're selecting from ownership plots, again, that's our shapefile, where the land use field is equal to urban and the municipality is a city. Here we select IDs 2 and 5. Notice that we didn't select 7 because its municipality is not city. In this OR query, we're selecting from our ownership plot shapefile where the area is greater than 20 and our municipality is equal to city. What this means is that, for instance, here, our area is less than 20, but our municipality is city, meaning that this whole row gets selected. Finally, this query is selecting from our ownership plot shapefile where land use is not urban. So it's excluding everything that has an urban designation in the land use field.